Hello, everyone. Welcome to this UTC webinar on options for electric utility distribution, fiber deployment, ADSS versus Lashed. This webinar is being presented by the UTC's Fiber Committee. Today we have Carson Joy, who's an applications engineer at AFL. He's going to be presenting on this topic today. As of right now, all the attendees are muted, so if you have any questions, feel free to type them in on the control panel. There's a questions box, and there's also a chat dialog box. You can type them in at either one, and we'll take the questions towards the end. Feel free to, you can also raise your hand and we can unmute you towards the end if you have any questions, you want to have some dialogue, we can for sure do that as well. So I am going to turn it over. First, let me ask Brett Kilborn, who's UTC's Vice President of General Counsel. Brett, do you have anything to add before we begin?
Just thanks for everybody joining the webinar. Just to let you know, the Fiber Subcommittee holds monthly calls, and this is a monthly call of our Fiber Subcommittee. So if you're interested in continuing to participate in the Fiber Subcommittee calls, please let us know, and we'll get you signed up and added to the list. Thank you.
Thanks, Brett. Okay, and so with that, I'll turn it over to Carson. Go ahead, Carson.
Sure. It's Paul Thompson. I'm the Energy Market Manager here at AFL. Good morning, afternoon to everybody that's joining us. AFL is a long-term supporter and active participant of the UTC, and we're delighted to have this opportunity to share some of our experiences with the group here. And we have a subject matter expert in our applications engineer, Carson Joy. So without any further ado, I'm going to pass it over to Carson and enjoy the webinar.
Thanks, Paul. Thanks, everyone, for joining in to this webinar today. As Surav had introduced, this will be options for electric utility distribution, fiber deployment, specifically ADSS compared to lashed loose tube. Just a quick introduction here on who AFL is and some of our experiences to be able to discuss this topic today. AFL started in 1984 as a joint venture between Alcoa and Fujikura, really with the flagship product of optical ground wire fiber for the transmission space that we'll touch on a little bit later. Alcoa is obviously the aluminum company of America that's been a part of the utility industry for more than a century, starting with aluminum conductors before even 1900. So when AFL started in 1984, Alcoa had that background with the utility market. Today, we truly do have end-to-end solutions available, especially for the electric utility industry, starting with fiber cables that we'll discuss today, the connectivity piece of plugging those fibers in, hardware accessories for aerial installation of fiber cables, service equipment for splicing and OTDRs, and then we also have capabilities of services and training as well to do full turnkey fiber to the home solutions and other fiber installations. So AFL is in a unique position with an understanding of both the optics and the fiber side of the technology, and also understanding the market of the utility industry too, where we really started back in 1984. So let's look at our agenda for today. So first, we'll really set up why utilities are looking into using fiber and have been deploying fiber for a number of years. we'll look at kind of the evolution of fiber from the transmission space, where it started and is still very active, and then more recently to the distribution space. We'll look at considerations specific to the distribution space for an optical fiber deployment, and that will really set up our conclusion of all dielectric self-supporting or ADSS fiber cable compared to lashed fiber cable in the distribution space. We'll look at some of the pros and cons and some of the key considerations for that kind of deployment. And we'll conclude and then leave some time for Q&A at the end. So the first obvious question is why a utility would look to use optical fiber, why utilities are using optical fiber. So fiber is a robust communications medium. First and paramount really for utilities is its reliability. This wired fiber connection is pretty widely considered the most reliable communications medium available today. Light signal that's used in fiber optics is not affected by electrical interference, which can be really important and beneficial for the utility space. Security is also very important, especially in the utility space. Cybersecurity is a hot topic today, and the encryption and firewall capability of fiber is really superior to copper and wireless capability there. And the scalability is also really important for the utility space. Fiber is a pipeline that's built to last. So electronics on the end of the pipeline are only going to improve. It's pretty generally considered that fiber has an infinite bandwidth, and fiber can easily be added and pushed deeper into your network, which we'll really touch on. And that's the scalability factor of fiber for the utility space. Many utilities are combining fiber and wireless technologies. So this presentation is not really a fiber or wired connection versus a wireless technology. As wireless capabilities improving, that's only going to require deeper fiber for that backhaul connection in almost all cases, specifically as private industries start to talk about 5G and small cells. Fiber is often not mentioned in those wireless discussions, but is a critical part of the backhaul piece, and the same goes for utilities. So the future of the electric utility is high bandwidth and low latency. So that's lag time communications, and that's really what fiber brings to the table. And these mission critical applications, as UTC report just recently released, talks about mission critical applications like distribution automation, AMI, SCADA, protection, video monitoring. All these, as these capabilities improve and are needed for the electric utility, fiber is going to be a key piece of those improvements. So that really leads us into grid modernization, the smart grid, and even full fiber to the meter, fiber to the home for broadband internet, especially in the rural cooperative space that we'll touch on. So looking at grid modernization, smart grid is certainly a buzz phrase for utilities today. The smart grid from a communication standpoint really means more data, more often, and from more locations. So Navigant has a good image here that really shows what utilities are very aware of in this change in the electric grid, where the legacy power grid was a simple downstream one-way flow of electrons from generation to their end user. But with the influx of distributed energy resources and other changes in the market, this one-way flow has really changed to a two-way flow downstream and upstream for the utility. And that kind of complication really means that utilities need a robust communications system to run their electric grid. Also hearing and reading from a lot of reports that utilities are seeing stagnant load growths with the influx of distributed energy resources and other additions into the market. So efficiency and reliability are are very, very important for utilities, and we're hearing that from many of them. And that kind of efficiency and reliability also is linked to a good communication system to be able to run your network at the ultimate efficiency that it's capable of. So utilities, they can't manage what they can't monitor. So communications are key for grid modernization efforts. More specific to that, specifically rural cooperatives, we're seeing taking on this digital divide of America, where rural areas are underserved with broadband internet, and the big national carriers are not willing to go to these rural areas due to slow payback on their investments. So the co-ops are taking on this charge, with broadband internet quickly becoming a necessity for our daily lives for many areas, and not just a luxury anymore. So many rural cooperatives are offering 1 gigabit speed with full fiber to the meter solutions, so taking fiber all the way to the meter. Gigabit passive optical networks are most commonly seen in this area, utilizing optical splitting, typically up to 32 times. So taking one core fiber and being able to split that light over 32 fibers, serving 32 separate meters, can make it cost effective, but still building that pipeline of a fiber connection that is built to last, like we talked about previously. And even recently, we're starting to see larger investor-owned utilities start to look into broadband for their members. Recently in Virginia, there was a bill that passed that allowed Dominion Energy, very large IOU, permission to provide broadband internet service to underserved rural areas. So IOUs are serving rural areas too, and the government is noticing this, and IOUs are starting to consider providing broadband internet to their members and consumers. So this is a simple graphic just showing the overview of electric power. So the video here shows electricity from generation to the consumer, and what it will also show is that using this same path, utilities can provide internet through optical ground wire and transmission space or other fiber mediums, and then pushing that deeper into the distribution space as well. So the utility right away is really well positioned to support not just fiber to the home solutions, but grid modernization efforts like we talked about with this two-way flow of data, and other grid modernization efforts. And fiber FTTX is truly fiber to more than just fiber to the meter or fiber to the home, so fiber to specific devices, or even just connecting substations for improved wired backbone communication. So let's talk briefly on some of the evolution of fiber in the electric utility. And that really started with the transmission space. Talked about AFL starting with optical ground wire in 1985, 1984 timeframe. So over 30 years ago, optical fiber was really designed specifically for this utility transmission right away. So large companies like MCI were seeing these transmission right of ways as a viable communications path to connect long distances. And optical ground wire was really a breakthrough technology, utilizing the topmost position on a transmission line, the static wire position, functioning as a dual purpose cable. So also providing the grounding capability of a static wire, but using optics and that light source that's unaffected by electrical interference to transmit data over long distances. All dielectric self-supporting cable, ADSS cable, is also used in this time frame for long distance transmission applications. A little bit different design, but the same concept that we'll be discussing in the distribution space. Extra high voltage ADSS has to look at a couple more factors like electric tracking or dry band arcing due to high voltage transmission lines. But you can see the picture there in the bottom with an ADSS cable in overbuild position. That's actually right underneath the static wire. Can be above the conductors or below on the transmission line. And then SkyWrap is that picture down at the bottom right, more of a niche application, but capable of the transmission space where an all dielectric cable essentially wrapped around either the static wire or conductor in hard to access locations. These are the technologies that we're seeing even today, especially today. The transmission right away is still a very viable source of transmitting data, both internally for the utility and for third-party leasing. Some of the high-level engineering, so sag and tension, these are long spans. These are very capable cables, high-strength cables, and then also the electrical characteristics like optical ground wire fault current ratings and other factors. And then we talked about overbuild and underbuild. So that really leads us into the distribution space. This is a little bit more recently used for utilities as they're looking to push fiber deeper into their network to support grid modernization, fiber to the home applications that we talked about previously. Lashed applications were in this 30 year ago timeframe when fiber optic cables started to be used in the transmission space, and it was a very easy transition from coax cables, copper cables that were lashed in a similar fashion, and ADSS cables. Really, about 20 years ago, the National Electric Safety Code in the mid-90s reduced and actually eliminated separations and clearance requirements for ADSS, which opened up the supply zone to be used for utility deployment, and some specific ADSS hardware started to be designed in this time frame, and this became a viable option for utilities in the distribution space. So we'll talk a good bit about the supply or power zone and communication zone. So here's a quick graphic to take a look at what we are talking about. As utilities, I'm sure are aware, so supply zone would be your conductors, but also your neutral. And this NESC code adjustment shows you could easily put ADSS either above or below your neutral in that supply zone. Your communication zones would be your telecom space for copper cables and fiber cables, typically lashed, and that buffer zone, depending on your distribution voltage, would be in the 30-inch to 40-inch range to keep those sections safely separated for line work. So that really sets up our further discussion in the distribution space. That was a bit of a history lesson, some of the evolution of fiber, how we got to the distribution space, why utilities are looking in the distribution space today. So some of the key considerations that we'll look at for distribution fiber deployment is obviously going to be cost for any major project. Obviously, the budget is a huge part of that project. Also, the design engineering, who's designing the network, what are their experiences and preferences. Make ready, we'll discuss a good bit, which is really any kind of pre-construction work that's needed to be done to your outside plant before installing fiber cables. Cable pole placement location related to supply and communication zones that we just looked at. We'll look into that a little bit deeper, comparing these two technologies. Your installation time and method of installation, the attachment hardware that'll be used, and what's often overlooked would be ongoing maintenance costs. So we'll consider each of these as we transition into the topic of the day, which is all dielectric self-supporting cable compared to lashed fiber, specific to the distribution space for electric utilities. So let's start with some pros and cons of each. So there's certainly positives and negatives, and every utility network is unique. So we'll look objectively here at some of the pros and cons of each of these technologies for fiber deployment. So we'll start with lashed fiber optic cable. So some of the positives of lashed installation would be installing in the communication zone does not require qualified line workers. Sometimes qualified line workers can be hard to come by or preferred not to be used for specific reason for the utility. And that's one of the positives of lashed. Network flexibility is a big discussion with lashed installations. The ability to overlash fiber cables onto an existing lashed installation is a big benefit, seen as a big benefit. So the initial lashed cable would likely be a messenger wire with a fiber cable wrapped or lashed on top of it, and that messenger wire would be capable of handling multiple fiber cables. So if needed additional fiber later, the utility can go back and lash another cable on top of what's already existing, which can save some cost. The fiber cable itself, compared to self-supporting cable, would be a lower cost as long as some of the individual hardware components are not as specific, so they can be a lower cost as well. Also, equipment can be placed directly onto the strand. This would include, for example, splice closures, could be attached directly onto the messenger because it has the strength capability to support that. Small cells or any other kind of equipment that would be desired to attach to the line. Some of the negatives of lashed fiber really start with loading. The messenger wire is a pretty heavy load onto any kind of existing structure, and installing in the communication zones can lead to some pretty significant clearance issues that could require, the loading can require additional guying, especially on angled structures, and pole changeouts potentially for the loading issues. Also related, that would be make-ready related. Also related to make-ready would be current attachments may need to be moved in order to comply with local regulations. That can add some time and cost to a lashed installation. The metallic component, so obviously your messenger is metallic and the lashing wire is metallic. And in addition to that, seeing some steel armored fiber cables, so your cable itself could be metallic. So it must be bonded and grounded, which can add time and cost and additional maintenance cost. Double pass installation will add time. So installing the messenger first, and then the fiber lashed on top of that. It's a larger surface area when you're combining, basically using two cables, the messenger wire and your fiber cable. It's going to be a larger surface area than ADSS. That could make your poles more susceptible to ice and wind loading, and then higher ongoing maintenance costs, which we'll cover more in detail. Some of the pros and cons of ADSS. The first would really be the loading addition. In general, ADSS is going to be about 4 times lower loading on your pole than lashed installations in similar environments, and that's pretty significant for make ready and loading onto your poles. There are no metallic components, so the all dielectric nature of ADSS is really beneficial, especially for the electric utility working with power. So cable can be installed safely in the supply zone, no bonding and grounding. There's minimal ongoing maintenance costs once ADSS is installed. There's not much to do. One pass installation, so no need to install the messenger first. The ADSS can be installed faster. And typically, and we'll do a comparison slide at the end, typically we're seeing ADSS installations as a lower total cost to the utility, which is a big benefit. Some of the negatives: working in the supply zone requires qualified line workers, which can be more costly and more difficult to find potentially. The cable cost itself, the ADSS, the self-supporting cable, would be a higher cost than your traditional lashed fiber cable. The cable itself doesn't allow for direct attachments. We'll look at some of the ways around that, but the cable is not designed to take a splice closure directly attached to it. Attachment hardware is diameter specific, so really minimizing diameters for your ADSS cables can be a benefit, but the hardware is diameter specific, and it does not allow for overlashing, as we discussed with lashed installations. So let's look at some of these key considerations for an ADSS or a lashed installation. So from a design engineering standpoint, utility networks are fundamentally different than traditional telecom carrier networks. Actually, a quote from a recent UTC report says that telecom carriers build networks to maximize return on investments. They are profit centers. And for utilities build communication networks to maximize reliability. So the difference really that we see between a telecom design and a utility design is the difference between maximizing profit and maximizing reliability. So those are fundamental differences depending on who is designing your outside plant distribution network. Some of the design options to consider for the design engineering of your fiber installation would be active Ethernet versus passive optical network. We looked at passive optical networks, and we discussed that earlier with fiber to the home. Splitting your fiber when you're going to multiple endpoints in a point to multi-point installation can be cost effective and also utilize the fiber still to its maximum capability. Active Ethernet would really be your point-to-point installations. They are more expensive because you're not utilizing the split, but for dedicated and highly important communications, active Ethernet can be used. Any kind of outside plant can be a combination of a point-to-point and point-to-multipoint on the same design. So it really depends on what's preferred for the specific situation. Population density can drive network design. So when it comes to passive optical networks, centralized splits versus distributed splits are often discussed. Your population density, typically for rural installations, we see distributed splits as more cost effective, but that's a consideration for the design engineering team. Network flexibility, as I alluded to earlier with overlashing, I think this also goes back to utility networks being fundamentally different. It's a difference between an engineer as you go type strategy and engineering it fully on the front end. So that can be the difference of even needing to overlash or add additional fibers later. It's really a full engineered solution to consider, or if you would like to engineer as you go and build as you go. We've pretty much focused on aerial, but here you see aerial versus underground. We see a lot of utilities going aerial because just of the cost of an underground installation. It doesn't mean that utilities don't utilize underground installations, but it is cost prohibitive in a lot of ways. But aerial and underground installations are relatively simple, either direct buried or in a conduit. What we would typically suggest would just be to follow the power. If the power goes aerial, then your ADSS or lashed can go aerial, and then underground can be your fiber going underground with power as well. Key consideration also, we've touched on make ready. So make ready is the pre-work to get your poles and outside plant ready for fiber installation. So that includes guying structures, moving cables, changing out poles, and really any other kind of pre-construction work. ADSS installed in the supply zone minimizes guying of structures and no need to move cables in most cases, or worrying about clearance concerns as the ADSS would be higher up on the pole. Lashed installations, especially in the communication zone, the make ready can add some significant time and cost. And this can be a major differentiator between ADSS and Lashed. And Great Lakes Energy in Upper Michigan presented at Tech Advantage last month on their make ready comparison between ADSS and Lashed loose tube installation. And they recorded that their make ready savings of choosing ADSS over Lashed was over $2 million for 17,000 poles that they had passed on a fiber to the home pilot project that they're working on. So that's significant savings, and that's where make ready can be a pretty big differentiator, depending on where you're installing and what your outside plant network looks like. Just briefly on one touch make ready, this is concept of one installer being able to move all the cables in the communication space to speed up installation. As the UTC would agree with, this is really being pushed by the bigger carriers, try to maximize their profits and time for installation. And utilities have been pretty vocal in expressing safety and quality concerns on this. So many utilities are struggling through one-touch make ready, and a good way to avoid that for a fiber installation would be installing in the supply zone. Another consideration would be pole placement, more specifically as we had touched on communications and supply zone. So it's the NESC section 235 is table 235.5, a footnote that states that no clearance is required between conductor and an ADSS cable. That's a big benefit for utilities. Many utilities installing ADSS in the supply zone are installing it 8 to 12 inches below or above the neutral, depending on where the neutral is. ADSS could also be installed in the communication zone easily, although this doesn't really take advantage of its capabilities and doesn't help as much with clearance. If needed, it could be in the communication zone. Installing in the supply zone offers a higher level of inherent protection. But in a lot of ways, I guess that's just common sense. Higher up on the pole would be more protected cable. The conductors are a little safer area for the fiber cable than down in the communication space. A brief note on Lashed installations in the supply zone. We have seen this a little bit more frequently, even recently, of utilities interested in using the supply zone with a Lashed installation. It's not the same as ADSS, obviously. There's still separation requirements that would start at least 16 inches, I believe. And it certainly could help with clearance, but the pole loading of a Lashed installation would also would not eliminate your make ready costs because guying of structures would still be likely. We've also seen Lashed installations with armored cable in the supply zone to help with rodent damage. Induction can be a concern in that area with metal in that space on the pole. And the bottom line would be that long-term safety must be considered for an installation and maintaining a cable that is metallic in the supply zone. And AFL does not see this as a viable option. So ADSS in the supply zone, just a brief graphic here to break down what that can look like. This is specifically for fiber to the home installation, although this model could apply for truly fiber to the X, any kind of endpoint. So you see your ADSS cable installed here just below your neutral in the supply zone, and then your splice closures and multi-port terminals, which are pretty commonly used in ADSS and Lashed installations or FTTX solutions. They're installed in the communication zone. This is preferred by many utilities so that splicing, ease of splicing, you don't need a qualified worker to be able to get into the supply zone to access the closure before splicing. Although that's not required, and if desired, the splice closures could easily be in the supply zone as well, just not attached directly to the ADSS cable, either to the dead end or to the back of the dead end. And then multi-port terminals with hardened connectors to attach to the home. In this case, you can see on the left drop cable going aerial, and on the right the drop cable going underground, and that's also a follow the power type situation where if power goes aerial or underground, the drop cable would follow it. Another key consideration would be installation. We discussed earlier what a one-pass installation looks like compared to a two-pass installation. This slide breaks that down. So you have your pole make ready for ADSS, which could be pulley placement or some minimal changing out of poles or clearance concerns or anything related to that, but typically minimal. You can install your ADSS, sag the ADSS, and then attach your hardware. And that's a true one-pass installation. Lashed would be your make ready, pre-construction, the messenger placement, the messenger hardware attachment, and then the second pass would be your fiber cable that would be lashed onto the messenger, and then bonding and grounding on top of that. So you can see some of the time savings related to an ADSS installation over a lashed installation, which could be advantageous to the utility. Next would be attachment hardware. So lashed hardware is not diameter specific, which can be a benefit. 3-bolt clamps, messenger dead ends, pretty straightforward, simple for stocking. However, although ADSS cable hardware is diameter specific, the total hardware cost we see in many cases is actually lower when you consider the lashed hardware to include the messenger and lashing wire. That can add some cost to your system. There's been some innovation in ADSS hardware. We talk about overlashing to add additional fiber cables into your network. You can see the picture here on the top right of a tangent hardware for ADSS that utilizes two positions that can be added. The second can be added pretty easily without needing to take down the cable or add another pole penetration point, which can be beneficial. Talked about splice closures not being able to be attached directly to the ADSS cable. It can be attached to the dead end and the back of the dead end, as we talked about in the ADSS graphic a couple slides back. But lashed does allow for components to be directly mounted, which could be a benefit. Another key consideration would be maintenance costs. As I referenced earlier, it's often overlooked, but there will be maintenance required once the cable is installed. And what we see are that long-term maintenance costs of ADSS are minimal, and Lashed generally requires more maintenance You can see in the top right picture what we've probably all seen driving down the road with lashing wire loose. That's a maintenance cost that will factor into your installation, and also bonding and grounding. The ground's degrading over time and needing to be replaced for safety concerns. And if there's any kind of damage, delashing and relashing cable can be difficult. We also see that because of the high loading and tension, there's no give in a lashed insulation. So pretty commonly you'll see, as in the picture on the bottom right, your wood poles could be broken based on that fixed point for a lashed fiber installation. While ADSS has the capability and is designed to slip through tangent structures, we hear multiple stories of ADSS being taken down to the ground by a tree and loosening up those tangent points and resagging your cable. It can be put back in place without any interruption to the network. So that's a big benefit for long-term and for storm damage and increased reliability. Utilities typically say that downwire reporting is almost always communications cable in the comm space related for lashed installations compared to ADSS. So the final key consideration before we get to the cost comparison would be design life and reliability. So your ADSS cable should be designed specifically for span lengths, sag, and environmental loading conditions that are seen in your area. So ADSS cables, AFL's ADSS cables, as we saw, are used in the transmission space. We have cables that have been installed for span lengths over 6,000 feet. So there's not really any loading too heavy for an ADSS cable. It just needs to be designed properly for the installation that's being used in. So design life, I would consider the environment where the cable is installed. We talked about the inherent level of protection for ADSS being installed in the supply zone. As you can see in the picture on the right there, your ADSS cable in the power space above the telecom space, the communication space with the lashed cables below. Although there's nothing significantly different in a outside jacket of a lashed fiber cable or an ADSS cable, it's really the internal strength component of ADSS that's the difference. So the longevity lifetime of the cable is not as important as the environment that it's installed in, and we see longer longevity in ADSS cables in the supply zone than lashed cables in the communication space. Talked about earlier the difference in the ice loading or wind loading for lashed cables being non-circular. Aerodynamic performance of ADSS can help pole loading. So finally, after discussing all this, wanted to show a general cost comparison with the caveat that all networks are unique. And this is just a general ratio comparison of field data that we've collected working with utilities on installations. And what we typically see is about a 20% cost savings for an ADSS installation when looking at the total cost of ownership, from cable cost to your hardware cost to make ready, installation, and maintenance as well. So the big differentiator, as we discussed earlier, in many cases is your make ready costs for a lashed installation in the communication space. Even here, installation costs for a strand and lash installation is lower than ADSS. That is debatable. We've seen utilities with a higher cost just due to the time of installation on strand and lash. So that can skew this even further. But this is just to give you an idea of some of the cost components that we talked about in the considerations. So conclusion here, electric utilities are facing unique challenges. We see that with grid modernization, and pressures to run networks at higher reliability and higher efficiency. And that's going to require a robust communication system and really going to require fiber closer to device for many utilities. And this is what's leading utilities to fiber for their communication source, and with a combination of wireless in many instances. So some of the key considerations when deploying fiber deeper into your network, specifically in the distribution space, would be design engineering, make-ready costs, as we touched on a good bit, pole placement, supply versus communication zone, your installation time and cost, and also your hardware, and your design life and reliability. So what AFL has really seen from a lot of discussions and involvement in utility fiber deployment is that following the power with ADSS in the supply zone really utilizes the utility right away to its full potential, saving both time and cost for fiber deployment. However, fiber really is unique, and the right products can vary on the electric utilities needs. So there's pros and cons to each, and each deployment is unique. But in many cases, we see advantages with ADSS. So all that to say, hope everyone enjoyed listening and kind of seeing the differences between these two installations, and be happy to take any questions now.
Wow, great presentation, Carson. So as a reminder, right now we'll move on to the question and answering session. As a reminder, you can still ask questions using the question pop-up on your GoToWebinar panel. So we have a couple of questions here. I'll go ahead and read them out loud if you want to provide the answer, Carson. So from Jeff Trofimuk, we have, does ADSS have a smaller diameter as compared to lashed cable? Examples of sizes?
I think the simple answer is yes. When you consider the messenger and the lashed cable combined, that diameter would be larger. Although looking at just the fiber cable itself, the diameter would be smaller because it doesn't have the strength component in a lashed fiber cable compared to an ADSS cable.
All right, thanks for answering that. From Bob, he asked, does little or no clearance between ADSS and conductors increase the risk of tracking, or is that a non-issue in distribution networks?
From our experiences, that is a non-issue below 69 kV. So pretty much in every distribution environment, tracking would be a non-issue.
Okay. Matt Sedgwick asked, where does the supply space end, at the neutral or at the fiber?
That's a great question, and I think often misunderstood. If you're placing fiber in the supply zone, you are resetting your supply zone. So if your ADSS is below the neutral, then the supply zone would end at your ADSS.
All right. just a reminder, if anyone wants to follow up, you can raise your hand and I can unmute you so that if you want to answer your question or ask your question that way. So from Mercy Salinas, what is the most common strand count that these utilities are using?
That's a good question. It can certainly vary. I think related to that question, we're seeing utilities maximize fiber capacity because relative to the rest of your cost, the fiber cable itself is not a huge cost element. Switching from, let's say, 144 fibers to 288 fibers, from a core backhaul perspective, I'd say 144 is most commonly seen, although many utilities recently are going to 288 for their core backbone too. And that's also related to what I was referencing earlier. Just the cost difference between a 288 fiber and a 144 fiber is not huge in the grand scheme of your entire budget, and is useful for future uses.
Great, thanks for that answer, Carson. We have a question from Brad Vanderwilk. Does ADSS have high count cables? Do larger count cables have smaller span capabilities?
That's a good question. In general, higher fiber count cables do not limit your span capability. It would just be increasing your diameter, which could increase some load on your poles, to be fair. But the strength capability is not different. I feel like there were two parts to that question. I don't know if I just answered one part of that.
Yeah, so do larger count cables have smaller span capabilities, and are they ribbon fiber?
No, we're not typically seeing ribbon fiber. Most 288, which is about the maximum we see, especially for the rural cooperative fiber to the home space, would be a loose tube fiber optic cable, still in a pretty compact diameter.
Okay, great. So we have from Mr. Cedric again. Is there a meter that allows for a direct fiber connection rather than to a collar that uses an Ethernet connection to the meter?
I think the short answer is yes. Although it's not an AFL product, but it is available in the market. We could take that offline to point in the right direction.
Mm-hmm. Okay, and from Mercy Salinas, should the utility work directly with AFL, or is an authorized AFL distributor the way to go?
It's really up to the end user, but we work with directly with utilities, and also work through distribution. It's preference of the utility.
Okay, great. And you know, a reminder, as an encouragement, we encourage our viewers to reach out to each other and to continue conversations. Slides will be made available after the presentation. I know someone asked that question as well. And I will be sending out an email with the presentation and it's the slides after the webinar within about 48 hours. Do we have any more questions? Okay. Hey, Bob, are you there?
Yeah, I'm here. Can you hear me?
Yeah, a little fuzzy. Did you want to add anything, or Brett, before we end the webinar? Okay, well, thanks so much, Carson, for this great presentation. A lot of good information there, and I will follow up with slides and recording of the presentation. As a reminder, UTC, we are here to serve you. Reach out to us anytime via email at itot@utc.org. We recently, as of yesterday, just put out our new utility network baseline reports. This has responses from about 50% of electric utilities, including Canadian provincial utilities as well. So this is a great report. It's available on our website, utc.org, under Thought Leadership. And you can connect with your fellow utility employees via UTC networks at networks.utc.org. Thanks everyone for joining, and this will conclude our call.
Thanks, everyone.
Thanks, Saurav. Thanks, everybody.